The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people were evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. There's still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, my group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Aloha everyone, I am geologist Philip Ong, here with Mr. Dane DuPont of HawaiiTracker.com, bringing you guys another Kilauea volcano update. Today, Thursday, October 14th, 2021. You guys are seeing a little sample USGS video here of the very common activity which has been ongoing for much of the last week here at the summit of Kilauea. So we'll recap what's going on for you guys here. We'll try to give you the rundown of what's happening right now first, and then as you guys if you guys are interested to stay and see all the prettier pictures towards the end, we'll make sure we cover all the USGS photographs as well later on, and make sure we take questions in the meantime. So Dan will be collecting questions in the chat, and we'll also be discussing those as we go and at a certain breakpoint during our broadcast. And he will also handle whatever he can in the chat and monitor that for any of you guys' feedback on our sound or video quality or any of that kind of thing, and let us know if you have any issues with that. All right, so now that we have that kind of our starting outline here out of the way, I just want to share with you guys what's going on with the volcano, and starting off with these videos of what it might actually look like. Really, it's been a week of people going to see the volcano national park, and I know there have been crowds, but people are posting lots of pretty photographs and video and all kinds of cool stuff happening. It's really a great time for people to come and visit the volcano. And that's really the bottom line. If you're thinking about coming, it's still going strong, and there is no sign of it changing in any major way anytime soon. We'll point out the little details that are changing on the monitors here coming up. So After having seen this first video from USGS, let me pause it here and maybe it doesn't want to pause. We'll advance it here. We're going to come back to 8th of October to show you guys this video we showed you last time, but this is a good example of what's going on with our west vent over here as a main source of effusion still. Most of the other vents are not visible anymore. They possibly could be coming up through the bottom of the lake, but we don't see them bubbling at the surface of the lake anymore. This is the only one visible at the surface, but it is visible from the Kanakakoi overlook within Hawaii Volcanoes National Park. So all kinds of fantastic imagery coming out, and we're going to rely on USGS mostly today here to share this process of the lava spurting up from this opening on what used to be the wall of the crater. It's now built this nice cone around itself there. And let's come back here to October 5th just to show you guys one more time. Let's turn off that wind, thanks. Thank you. And you can see this what I wanted there. You guys can see the rim here, the spatter rampart coming around. Okay, let me fix this issue here, and let's find out what's going on here. My annotation tool. All right, put you back, and here you can see this. There's the rim right there.
John Madden has actually possessed your pen finally.
Yeah, a lot of little checks I've been trying to do to get ready here today. Has had some issues, and I apologize for that. And that one did not go as planned there, right there. So, but that's the basic happenings here. Lava still coming up at this western vent. It's building up this cinder and spatter cone. Maybe mostly spatter around here, even more cinder on the outer parts. And there's a little gap here. This little gap that's spilling from this crater into the lava lake right through there. And according to the USGS reports, this is on the order of 30 feet across, 9-10 meters or so. To give you some idea of the scale of this, when I read that number, I was a little surprised that it was actually that wide, because the shape of this thing, it could be any size without any scale down there. And of course, the scale is something that we've been playing with for a long time, and it's extra hard when you're zooming way into these features far away. So great to have the laser rangefinder measurements from USGS, and that confirmation from there to there is about that 30 feet. That's that gap in there. The other thing you really can see in here I wanted to point out is there's this big chunk right here in the middle of this flow right there, and maybe I can get myself yellow so you can see a little better on lava here. There we go. That it looks like a little islet or so, but it actually resembles more so a piece of this rim of the spatter cone that perhaps flopped in here. And we'll see on a time lapse there's quite a lot of dynamic changes in the shape of this spatter cone happening around here. So this is one little minor detail to point out there. That's our visual of the fountains here, and another popular image this week has been this comparison of scale of the Empire State Building put within Halemaʻumaʻu crater back to a little over a year ago, when there was still, or a little less than a year ago, when there was still water within the crater, and putting the Empire State at the base of that. The previous lava level might have been down somewhere in here, right halfway between these two oranges, because this is bottom orange surface is the lake surface 3 days into the last eruption, which was most of the gain, but it actually crept up quite a bit afterwards as well. So this one is not the full first eruption, but just the first few days, first phase of it, but a good point of comparison compared to this upper crater here, which was after about 1 week of eruption of this most recent eruption here. So you can see we're filling the crater quite a bit, up past the 70th floor of this theoretical Empire State that would have made a very interesting Empire State mold in there, right? Not quite a tree mold. We've seen tree features, but maybe we'll just stop that tangent right there. But you guys can see here for comparison the size of the crater compared to that. And so we'll come back to that in a bit here, but you can just keep that comparison in mind there as we go through the images here. All right, so one of the first questions I always have, and people always ask, is how far up is the lava lake coming? The lava lake is still rising. We have a big gap in the data here, transmission, for much of the last week, but we can see that the pattern is roughly the same here. It's basically been trending upwards here. There is a little curious jump right in here that happened late on the 12th, perhaps, or middle and late on the 12th here, a couple little jumps. And the last time we saw something like this, it was actually one of those pieces of the island drifting into view of the rangefinder, causing a particularly large jump in the signal there. So we'll wait just confirmation of that, or explanation of what actually is going on there. But overall, we can take that the pattern is still this generally rising level right here, right? So according to this chart, we're up at over 268, perhaps 268.5, we'll call it. Hard for you guys to see all that in here, but that's 268 right there, and that would be 270. So maybe not quite 269, somewhere between 268 and 269 meters of depth to the bottom of that crater prior to the first eruption back in the end of 2020. So that's the point there, and this is notable. We'll show you why in a second here, but here's the overall pattern of the first initial rise, and here's that first jump of where we actually had the laser rangefinder pointing at that rising island, which caused it to artificially rise. They're saying back to the first, so they're saying even as far as over here, it was actually, this whole section was artificially raised because you actually weren't shooting a lava lake surface, but rather one of those islands that was rising. And so they reset it right here and put it back to the lava lake surface. And so here is this true value once again. So something like that would have been the real line. And that's why when we scroll over here to the right and we see this other gap and this other bump, you just have to wonder if something similar might be happening. Still, the pattern seems to be accurate, that it's going up in that slow rise right there. And so that's the depth there, and this is notable because I've seen several people posting. Give a shout out to Nathan, who's our buddy Nathan, who's tracking earthquakes and depths and things and making some interesting posts on Hawaii Tracker. But we're going back to this comment by the USGS in a Facebook post that goes back over a week now. But the question here is still relevant. How many feet to the low point on a ridge where it might spill over from the innermost crater, which is the next question everyone's wondering, how far it's coming up and how far is it from the edge, right? So they note there that it was changing every day, but really close. 10 meters, around 30 feet. Keep a watch on this graph. When a depth reaches 267 meters, lava will be in the lowest ledge. Okay, so that's, I'll add a caveat to that, of course, here in a second, because we're interested in the most detailed analysis we can. But as well here, there's a notable second comment down here. Why is there discontinuity in the graph? And here is where this information comes from. On October 1st, a piece of the old December 2020 west vent rafted into view of the laser rangefinder that's measuring the lake surface. On the afternoon of the 4th, a team went out and re-aimed the laser to be pointing at the lake surface instead of that floating vent blob. So that's where that info is coming from right there. I wanted to show you firsthand. But let's go back to this 267 meters, right? That's the level of lava on the graph, right? However, we have to go to the USGS update to remind ourselves. There's all kinds of information in here. A lot of it's repeat, but a lot of it's new. But I'm going to jump down to the point where it actually mentions here that the lava lake is not level across its surface due to the location of the vent in the western end. Areas closer to the vent are about 1 to 2 meters, 3 to 7 feet higher in elevation compared with the north and south part of the lake. That's kind of the middle. But the far eastern edge, the one that's closest to that lowest spillover point, is a full 9 meters, 30 feet below that west vent. Right? So really, for that lower east end vent to reach that 267, if we're 9 meters higher over at the west vent, we need 267 plus 9. Right? So 267 plus 9, 276. And now we go back to this graph and we can say, okay, well, that explains why we're not actually at the spillover point. The actual elevation of the west vent is above that point in the northeast, but that closest lava is actually not. It's a little bit, because the whole thing is, it's hard to describe it as actually tilted because it's likely more level near the lava lake, but certainly that level area is perched up and then there's a slope beyond it that goes down towards that eastern edge. And we'll look at that in some detail here coming up. But that's the bottom line here. The lava is still coming up. It's not quite into view. It's getting close to that area, but it is not quite there. Right? If we come back to the update, the next question we often get is, how long might it last? And that's really hard to tell. And we can look at the signals of the deformation on the volcano. But also we want to know the gas output, because the gas output's our best proxy for the amount of lava coming out as well. So we seem to have settled into this range of roughly, I'm going to call it roughly 5,000 tons per day, right? We're actually at 4,400 on the 13th, was a little higher before that, a little lower before that, but in this range of, 4,000 to 6,000, 7,000, and generally coming down fairly slowly. We can show you the details of that shortly as well. But the rates are still in the thousands, which means that, it doesn't seem to be waning off anytime soon, even if it is perhaps cresting, it's put out most of its gas already. It's still sustaining a good amount, and there's no sign of it waning off quite yet. So, all right, there's some other details in here. Maybe the only noteworthy thing besides these a lot of numbers to keep track of is that the total volume erupted since the beginning of the eruption is estimated to be 4.2 billion gallons on October 8th, so a full week ago now, right? So 16 million cubic meters. So we're probably upwards of that. We'll give you new calculations when we can, but there it is. All right, and here's where this number, 10 meters, 33 feet wide opening facing east toward the lake in that spatter cone. All right, and that's most of it there. No unusual east drift observations, no difference in the hazard analysis. We did have some gas impact this last week. We'll discuss that here shortly. But while we're on this topic, what everyone wants to know is when might it actually spill over. Let's just keep focusing that a little bit longer. And we'll turn to first this last 24 hours animation of the B1 camera from the USGS. This is the one that's on the east rim facing towards the west. So this is the west vent over here at the back with all this brightness in the nighttime. And this is an area that's higher, and you're saying that it's 1 or 2 meters higher than here or here, and it's a full 9 meters higher than over here, right? And the reason that I want to look at this camera as our possible spillover watch is because it's this little corner right over here, this edge of the crater right in there, that the lava might spill over. It may actually happen right behind this little rock right here, so that might be kind of interesting. But this is the point where we might see lava coming out. It might be somewhere in here when it actually does make it over. This is the lowest piece of that wall right there. And so interesting to note that with this view, that level of lava right there is actually right about the level of this edge over here. And so really there's a trench, a couple of trenches, a trench down over here. And then this whole area over here is actually lower than this brighter spot where the lava is flowing and getting perched up here, closer to the west side. Not the best angle to see this from, and of course, this day and night with the flashing is a little bit annoying. So we're going to turn to a time lapse compiled by Dane here of the B1 camera from the beginning of the eruption here. So we can see our spillover points is back over here. We're looking at daytime only, and so you can see a little bit of this development of the perched rim of the lake at the edges and how that trench might exist over there. Right in between there, you see that shadow a little bit. And so really, as it perches up on this edge and spills over here, it's this lowest edge that has to be at that highest level. So you can understand why it's gonna drag on a little bit longer. And so not quite clear if this would happen by our broadcast next week. It very well could, but we could also be talking about how close it is next week as well. That's about the uncertainty of the dynamics of this. Even though we have a lot of lava coming out, it's got to make it all the way over to this eastern edge. And that is something that has been happening periodically, but not constantly. Okay, so let's move on from this B1 camera because, as you can see, we can see a lot of this action on the eastern side, but it's kind of hard to tell what's going on in all that brightness. So we're going to turn now to our F1 thermal camera and dive into that in several different ways. So we'll start off with this last 24 hours here, automatic from the USGS, just to give us a snapshot of what's happening right now. And down here at the bottom is our west vent. I'm going to go back to my yellow here. There's our west vent. You can see it's spattering up, and the cone itself here is visibly changing shape even over the last 24 hours. Something we can look at as well. You can see there's a big chunk that seems to have fallen in, and then gets rebuilt over the course of the day. And that's a very dynamic area right there with the lava fountaining up and building that cone around there. You see the entry point right in here where the lava is plunging in, and from there it radiates and disperses out in all directions from there. And that's the basic pattern. You can see our central island here is blocking most of that back eastern part, which is still largely an intact crusted area of the lava lake right there. And we have down here our old west vent island, which now seems to be fixed and actually moving in sync with this larger central island there. And that's most of it. You can see there's a little bit of a perched edge forming perhaps right there. And that old southern vent that used to be further over here, all the way gone, the exit point that seemed to be over here, now seems to be somewhat near this edge of this perch pond, and it's not quite clear here how much of this is actually spillover and how much is actual issuing from that old fissure through that crust in that area right in there. So that's a curiosity, a minor curiosity, but that's something to look into in the future. Keep your eyes on the future as well. So you see just in the last 24 hours, lava in the south side is spilling over to the southeast corner a little bit, not as frequently. It's not constantly flowing like you see back here closer to the vent. This is that edge that you can see from closest to Uekahuna near the old Jagger Museum area, is looking at this. So you might still see some of these spillovers and crustal overturning events happening still in that area, in that little corner. But that's not happening everywhere across the lake, as you can see further back over here. Right. Looking over here further to the south, this is actually the west, the bottom of the picture here in the west fence, so just north of that, you can see a little bit of a perched edge right here, but it's spilling over fairly often into this trench that's forming behind this perched wall right there and attaching to our old west vent island right there. You see this little gully gets flooded over and over from flows from both directions here as it spills over. Whereas back on this far northern side, which is where I was trying to get to, you see the flow actually splits. There's a little bit of northwest and a little bit more north, and seemingly still has a perched ledge all around through here. But it's constantly spilling over on this northern area and filling that trench back that way. And it's constantly spilling over to the northwest here and filling this area over here as well. Right? This little ledge right here, part of this perched pond area here, this looks like a bigger island now, is actually part of that perch ridge. This thing is actually moving separately from these other islands. I'll have to show you that in a time lapse. But this piece of it's still moving and mobile. This might be shallower. A newer feature, part of that rim, still building and adjusting with this flow, rather than these older blocks that maybe have an attachment to the rest of that crust down there. So those are the interesting details we can kind of glean from 24-hour orientation for the last day of what's happening now. So having done that, we can now dive in a little more detail. This is just the last week here, and I will play it here in a loop for you guys. Just the last week. Once again compiled by Dane with a sourcing of images from the USGS by Dane and Bob Martin. Mahalo, you guys. So over the last week, a little bit better than the last 24 hours, you can see a little bit more. Let me zoom way in here to the new west cone, so you can really see the development of the cone as it grows here, and it grows and collapses and grows and collapses and grows and collapses, and it seems like it's doing that. It's almost like jerky, and it's not all the same image playing over and over. It's just repeating itself over, every day. Parts of it collapsing in, and other parts rebuilding there, right? So, and you also can see, if you look closely, I'm not sure how much more I can zoom in, but you can see a piece of the wall rotate over right in there, right in here. Piece of that darker purple, you can see gets pushed out of the way of the vent there. So that might have been a piece of the island that we pointed out in one of those earlier videos. You really can see how it's really changing, and more. Sometimes it's more here on this western side. Sometimes it's more on the southern side. You can see at the end, the southern side gets quite tall. You can also really notice how the fountain heights really here are noticeably varying. Right, there's a period through here where the fountains are quite a bit taller than the beginning and later on. And that's the period of time, I want to say the 12th and 13th, within the last couple of days, where there are reports by the USGS of fountains up to 98 feet high-ish. So about 100 feet tall lava fountains coming out of that vent that's bubbling through the edge of the crater and has now reached the edge of that lava lake. So pretty amazing stuff there, and this is why this is fantastic viewing time, because you can actually see this lava fountain and these occasional higher bursts from that park overlook, and the higher this lava lake comes, the more that'll be visible from other places as well. Really, 100-foot bursts in the air, you could have been probably many places around a caldera and seen the top of the lava during that point in time. Right, so last week, dive in here. That's the west vent area. You can see a little bit more of the pattern of circulation here, how really it's you have these more active areas we just pointed out to you guys, but there are occasional, you can see here like a surge, a couple of surges where you see this back part of the crater does get flooded. There's one pulse, and there's another one happening kind of at the tail end of it right here. So there's one at the very beginning last week, and a second one happens in midweek, and then a smaller one just in the last couple of days, perhaps coincident with that west vent cone growing there, right? So interesting to note that there's this kind of surging or pulsing. I'm not quite sure which word to use now and what the right context is compared to what we saw in 2018, right? So maybe pulses might be better in that context, right? You see pulses of more lava coming out, and when that happens, it could be that it actually is overcoming these perched edges here, and that allows it to flood down and eventually to this lower area that's actually lower than the west vent, flood onto it as well. And then so you're essentially having a terracing from, you know, higher in here, and then slightly lower in here, and then the lowest is actually back here at the back edge. So that's really the overall pattern there. There's a lot of other stuff in here, so let's keep going on this last week to really see what else is going on. Not only do we have this main west vent and this growing cone here, but there's a little other curious feature that's pointed out by several of our viewers. Mahalo, you guys, in the comments throughout the week, of a second little vent appearing down here on this northern side, right? The USGS reports this was fairly short-lived. I want to say they said 10 hours or so. I think there is a picture we'll see in a bit. And I think I saw one of our viewers, sorry, I don't remember the name right now, but annotated this one as our West Vent 2.0, West Vent 1.0, and this one as West Vent 2.1. Right, the little new version of it that came out. Perhaps the same fissure line coming through the lake, but maybe gives you some hint that it's not just one exit point, and it might be bubbling up through the lake in other areas, like more obviously here, but perhaps other places as well. That's the little bit more on a vent. I think that's pretty cool to see that vent growing, collapsing there. The spillover points are really hard to see here. You see that these seem to be constantly spilling over or emitting lava from that perhaps fissure down in there. Hard to tell. And really this back area, zooming into it, you can see the occasional flood of lava coming across and adding a new layer of pavement. It's cooling differently from the rest, right? So there's still liquid lava underneath this whole area, and it's still rising. And that's something we can look at next in our bigger picture patterns. But there is one more thing I want to point out, and that's back here along the back wall. Right? So you can see there's definitely lava coming in and filling the trenches through here, and from the sides here and here, and it's hard to always tell where this lava is coming from. It could be spilling back over here and going on a trench a little bit out of sight and then reappearing. But there is a hint occasionally that there could be some lava coming up between this old crust and the crater wall in there. It's really hard to tell from this view, but when we dive into it a little more, I'll pull that frame out so we can look at it a little more closely and a little more slowly as well. But before we go slow and I go to ultimate fast here, here's our whole most recent eruption, all sped up really fast within 5 seconds. So there it comes, fills in. You can see the initial vents, and then you can see the rising and crusting over, and the flooding pulses here. A couple of them at the end, coming up and flooding, right? So I'm going to actually pause this one now. I want to make it even faster. I really want you to see the effect of how the crust is still rising up and down here. That's the general pattern. The west vent is coming up, all the islands are coming up, and maybe you can see, maybe I'll play it one more time again with a loop. Maybe you can see now that this new rim island here, this one's actually moving a little bit separately. You can kind of tell that here at the end. But I think it's time to slow it down, look at our full time lapse here, and see what I can find you guys first here. All right, so looking at this back wall, there are areas in here that this crust overturning is still happening. You can see this might be a flow coming around a corner here. That's something we're curious about. And as we watch it across time, there is a frame that I saw right in there. And keep your eye right in here. I'll play it, and you'll see that maybe there's a spot that comes up through that crater wall first, right there. It seems like maybe it comes up first, and then this thing comes around. And that's why the question exists right there. It's exactly what you're seeing there, right? And maybe if I put it back a little, it's going to be hard because I can't zoom it in and pan it at the same time. There. Right. That's the frame I want. So you can see here quite a bit of a separation between that channel flow and a gap in the wall and this little bright spot. So maybe it's a little pool that's overturning as well. That's also possible. But this does bring up the question of whether we're seeing those squeeze ups that we saw famously during the last eruption as well, coming up through that gap in the wall. Right. So keep your eye on this island over here as it comes up as well. Right there you can see it wiggling a little separate, right? And maybe I'll point out right here. In this frame, you can see that the edge of this tip is actually touching the edge of that one right there. And if I rewind it, you see that those coming up separate and are rotating together right in there. Okay, so that's mostly it. I won't have to dwell on this forever. You can see the various pulses coming through here, and that's overall the idea of what's going on here. I'm sure there are other details we could pull out, and maybe we will when we answer some of your questions. If there's anything that fits in right here, then you can feel free to jump in, Dane. But I can maybe take a quick look here.
Yeah, go ahead, and we'll just get the questions afterwards.
Right, I think we've done some of these already. The difference in the edge of the lake and the western and eastern ends. We talked about that already. And all right, so let's do a little more of this data dive here. Deformation, the tilt. The tilt is actually now no longer deflating, and that's an interesting change. We'll look at how significant that may be. It's hard to tell quite yet, but you can see that our scale here is from +1 to -0.8, so 2 microradians is not very large. But it is an inflationary trend, very, very, very small here. And looking at the last week, what you can see is that prior to this big spike, which was a big earthquake we'll talk about as well, we had a 6.2. That shook all the tilt meters everywhere. So what actually happened there is, might be hard unless I zoom way in, but we have been having a deflationary trend for the whole eruption thus far. And actually, a few hours before that earthquake, the trend flattened and started to rise. Now, we have to, for now, we're going to ignore this little section of the graph, which was the earthquake shaking. So the rise is here, the rise continues, and the rise slows. And it might be deflating slightly and inflating slightly, but it's basically, in the grand scheme of things, fairly flat. Right here, you see a little bit more coming down, a little bit more coming up. But in the grand scheme, this is 0 microradians, this is 5, so this might be a 2 microradian change in total that's going down and up there. So it's hard to say that it's going up or that it's not, or that it's staying flat, but what we can say, it's not going down. That's the main takeaway message. And when it was going down, that was the sign that we saw during the last eruption. Once that flip occurred, that the volume of lava started to gradually decrease and go down, and volcano started to swell as not all the lava coming into it. And the subsurface was actually getting out at the top, which is often what the inflation might mean. So interesting to note that there's inflation here. A little bit of inflation, not constant, but definitely not deflating. Things are definitely moving and adjusting in that area right now, and there may be some effect of this lake rising to the elevation of that vent and starting to drown that vent a little bit, as we saw during the last eruption, where that might be what actually eventually is able to turn off that vent in the long term by slowly flooding it over time. So that may be what's happening. It's just an analog to what happened in the last eruption, and a possibility what's happening here, as we know that the lava lake has been up near that vent base level for a while, really, since about a week into it or so, I would estimate or so. So the overall grand pattern of the last month of tilt here We had that kind of build up right before the eruption right there, very short-lived, and then the deflation has gone on for quite a while, bypass the earthquake, and right here at the end, this more flattish zone. And that's the change we're talking about right now. So that's the fascinating part there. The GPS is still same trend, no obvious trend change there. This is often a slower developing signal, so no surprise that it's not registering yet. We're just going to wait till that is more obvious next week to dive into GPS further. But similar trend over in East Rift Zone by Pu'u. Still very small scale magnitude, but same trend there. Okay, so a little bit more in a tilt. There's some interesting stuff here. Let me make sure this is fresh for us. Okay, so that's the station we're just looking at, Uikahunan, and the northwest part of the caldera, right there. Sand Hill, which is a station closer to that intrusion area, got really shook quite a bit during that earthquake. You can see the scale on this graph is ridiculous. Minus 300 microradians and plus 50. Right? In comparison, the intrusions, were nothing compared to that, right? Back here. So don't really see a whole lot, but the blue line goes, you can see it goes down slightly and up slightly. So essentially mirroring that pattern at Wikahuna to the best of our information here. Summer camps not putting up data at the useful time period. And Kilauea, you can see, has also followed deflationary pattern, and it has had more of an inflationary pattern over the last several days here, with a very curious little spike here just happening in the last few hours today. It's not quite clear what this is. What is obvious from these plots is that it happened very locally, right? So it's not, if it was an earthquake, it was an earthquake that occurred very near Kilauea. However, it doesn't have that same straight up and down pattern. So you got to wonder if there's some magma movement happening over in that eastern part of the caldera underground as well, and in the Kilauea area that's perhaps part of this adjustment, right? Remember, we have this whole caldera reservoir area under Halemaʻumaʻu in a shallow area, deeper under Kanakakoi in the South Caldera area. Then we also have the connector to the Upper East Rift Zone that goes by Kilauea area as well. So there's a lot of networks that occur at various levels of the volcano in the shallow areas there that could be having magma move between them, perhaps. And so it's a very, very small signal here, but a curious little thing. The scale is 5 microradians per hash once again, so this might be a 3 microradian signal. Nothing super alarming, but it's kind of curious why you'd see a signal just there, or maybe it's something working, some human effects nearby. That's always possible as well. But elsewhere on the volcano, Escape Road, Pu'u, we're still seeing those same patterns, deflationary patterns, and really no change. With the earthquake signal, essentially a flat line at Jonica, the furthest towards the lower East Rift Zone that we have registering here. So nothing to worry about anywhere else, but interesting little variations within the caldera area right in there. Okay, so moving on to the gas now. The gas is something that is our biggest impact of this eruption. I keep talking about how it's a great time to come visit and see the eruption right now. The biggest human impact is not lava, but it is a gas. The gas is common during most eruptions, but it's still worth talking about, especially when it actually causes an impact, like we had the schools in Pahala close last week Friday because of high SO2 particulate readings. And it's just a standard shelter-in-place plan that they followed, devised by the state, DOH, Department of Health, and Department of Education, and nurse practitioners and other medical staff as well. So everyone was fine in the end, but worth noting that the values are spiking. We'll look at that in a little more detail. But big picture, 1-year plot, the gas values have come down quite a bit, similar to what we saw during that first eruption. That first eruption came down quite a bit, and then it dragged on for months and months and months and months before it finally ended somewhere right in here. And so at that point, the gas wasn't really that helpful, except that we were down near, getting close to these low values before that actually happened. It kind of tailed off slowly. Right, and those values, I would say, once we're getting below 1,000 or so, that's perhaps that tailing off section, right? So we're currently in a 5,000 range. We're still quite a bit higher than that. There's a last month where you can see zoomed in before, no eruption happening, first day of the eruption, and quickly tailing down, and then dropping off with some little wiggles, little variations here, right? And this might be related to this kind of pulsing effect that we talked about, how we have different amounts of lava coming out over time and visibly affecting the crater floor in noticeable ways there. So little variations are expected, and you can see there that their overall pattern is down. The scale is still really high because of this super high 85,000 ton value. So it'll be a while before we see more resolution in here, and it's going to look like it's low for a while. We'll look at the numbers from the report as our better indicator there. Ambient, you can see closest to the summit, up to 14 ppm SO2 registering on the ambient meters. Slightly further down at Cone Peak, you see 8 ppm on the meters. Slightly further down, over at Pu'u. Recently, it's been more in a 5 range, but earlier up to 8 ppm as well. As far as air monitoring, we're gonna skip that map for now and come back to it in a second. Within the national park where the viewing is, everything is green. Not a whole lot of change there. Everything's been green all day. Most of the gas is blowing away to the southwest away from there, as a VOG forecast that you guys see here suggests, right? So the red area is where the most concentration. That's this Pahala Ocean View area, South Kona, Miloli'i, but also wrapping around to the southern edges of Hualalai here as well. So that's the VOG forecast, and VOG is still a big issue for everyone here in South Kona and South Hawaii as well. All right, so this is the Hawaii short-term SO2 advisory page. This one is one I just want to mention that's out there. It's linked to in a lot of places, and most of the time it's measuring just SO2, not particulates. So often, almost always, I see it as green. I don't find it personally very useful for that reason, because it's almost always green doesn't tell you a whole lot if that's the case, right? And it's only measuring SO2, whereas we know that the VOG is more SO2 rich closer to the source, and it's more particulate rich further from the source. So as you get around to Kona, you don't expect as much SO2, but more PM 2.5, and maybe Pahala might have the highest chances of having SO2 coming in. So we're going to move on from the SO2 air quality data and go to this the statewide map here, which is measuring SO2 and PM and other gases as well. So it's also showing everything is green, although you see that this Ocean View 41 is pretty high. I'm getting close to the edge of the yellow as well. And it's possible to come through here and actually click back through the days and see that yesterday, Ocean View actually got into the yellow for several hours, and the day before that it didn't. The day before that it almost did. The day before that it almost did again. So you see it's quite variable, but it's been borderline at Ocean View. It's something Ocean View people are often not mentioned, but they're getting it as bad as anyone consistently anyways. There are other parts of the island, like Pahala over here, which may not have it as bad as often, but once in a while, let me rewind here. Once in a while, if you go back to last week, it'll come up and you can see it was actually up here in a yellow. And last week in the 12th was in a purple. I actually got into the purple, past the green, past the yellow, past the orange, past the red, into the purple. That's the 12th, and you can see that before that was just yellow. The day before that it got into the orange. The day before that it was almost to this darker purple, in fact, right? Didn't even know what to call that level there, but see how many rainbow stripes we have on that plot. And back on the 8th, that was last Friday. Actually, school was in session during these morning hours when they actually had to prompt that in place, lockdown with no one going outside, kind of thing. Right? Whereas you can see in these later days, Saturday in the morning, but no school, right? People were around town, had to adapt, I'm sure. Sunday got high. Monday was high. Tuesday was high, but it was high between 6 and 8 p.m. So you can see once again, it's no school effect at that point. The school effect is just something that's notable, right? It's something that you can document as a data point that actually is an impact. Even though other areas you can see might have just as bad of a VOG, there's no public mass event happening, being canceled or delayed to actually note the impact on the communities there. But it is happening, and that's why I want to go through this in some detail, right? this is only one way to look at the data, of course. Like clicking SO2 only, we can click on a PM only, right? But this is actually all of it combines the readings, and you actually can be in a red and Kīlauea Kona from the PM and Pahala from the VOG at the same time. So it's an interesting one to look at in that kind of context, right? We could also, I didn't load it up here, but I'll pull it up real quick here. Also look at purpleair.com. Let's look at the map. I want to know where I am, so I'll click OK, so it'll get me to Hawaii right away. And you can see that that one actually is registering more of these PM effects all along the Kona coast there, right? So the state one doesn't show necessarily as good of these values, but the thing is that Purple Air, if you guys are wondering, is not measuring is measuring this PM 2.5 rather than SO2, and so we kind of have to rely on both. And also note this big gap and no Purple Air stations anywhere in the south part of the island near the volcano. Right, so this is a good site for us to examine effects in Kona, but we need both that state one and this one to really get what's going on here in Pahala especially. All right, so move on from there, and not where I'm supposed to be. Come back to, what's that? Here we go. All right, that was a gas. Looking at the earthquakes now, here's a map of the earthquakes on the island over the last week. You can see there's a lot of these outer off-island adjustments. So what we call these flexural or settling earthquakes, as the whole weight of the island is essentially, I think of as the whole crust of the ocean like a big waterbed, right? And so the big fat island is shifting its weight there, and it's just causing all the areas around it to adjust to that shifting of weight there, and it kind of piling higher with more and more lava, but also sprawling, like causing that flexure to adjust and right outwards. So it's common to have those, and we've been seeing those outer ones for a while. But also we've had that large event at 6.2 that occurred right in here. As you can see, it was on the 10th. It was really deep, 35 kilometers down. That's about 20 miles or so, so very, very deep. And if it was something shallower, you might think of some kind of adjustment, and then you can start thinking, okay, well, maybe there's Loihi nearby. Let's see if we can get the bathymetry layer here. Right, Loihi nearby, over here. You can see that Loihi is actually off to the side compared to this adjustment zone. So it's an adjustment between Loihi and Mauna Loa, perhaps, something like that. But really, it's too far down to be really between them. It's more at the base, the flexure of the whole stack altogether. And you can see quite a few aftershocks that followed as well there. If we can scan these, and these are all in a 36-kilometer range. Every single one on this map, and following that 6.2, which was widely felt. It was felt all the way to Oahu. The earthquake waves registered across the whole continent, as is typical with earthquakes of this size. But that essentially is an adjustment that has nothing to do with a volcano, and is more of the depth of these earthquakes where the feeder source actually is, right? And this is what we're imagining magma is coming through. So it's actually separated from that area as well by a big distance. And that's why the most natural conclusion is that flexural adjustment right in there. Just to see what the same map shows for Kilauea, very little activity in a summit region, one event here to the northeast, and still some sparse south flank events going on over here. But before we move on from that 6.2, I just want to mention the USGS that issued an information statement here with no effect on the volcanoes, and maximum intensity of shaking of 6 here, Roman numeral 6, strong shaking. Right, so that's as they put it here, different way of saying what we just said. That Dane actually posted that right away when it happened, and we're repeating the information here. The depth, location, and recorded seismic waves of the earthquake suggest a source due to the bending of the oceanic plate from the weight of the Hawaiian island chain, a common source for earthquakes in this area. No impact, no change in the warnings. Move on from that. Right, notable, exciting. Some people, because of the location, were considering the exciting possibility that maybe there would be a new hotspot coming up right through here, right? But there's really no shallowing of earthquakes. It's really all in one cluster, which leads itself more to an adjustment rather than a pattern of a new volcano coming up. And you wouldn't expect that either, just because you already have a pathway from this common source area to the volcano that already exists, as we saw, in earthquake swarms recently. The most recent one was last year already, Hyundai. It seems like now it's been a while.
Yeah, definitely.
Okay, let's see if I can finish off the earthquakes, and we'll move to some questions. Focusing more on Kilauea. Just Kilauea here, the earthquake numbers you can see have gone down quite a bit. We're still very, very low. In fact, we're registering less than 20 earthquakes per day on this month-long plot here. Right, this is kind of our intrusion era back here. Well, no, actually, no, intrusion scrolled off. I'm sorry. This is our resumption of earthquakes of seismicity before the eruption. Day of the eruption right here, and then ever since then it's been low. And then looking at the red line, that's our total moment, so that's where 6.2 occurs right there. That's only one event, so it doesn't really add to the counts as much as it does to the moment. That's what the red line is a proxy for. But because we're capturing this area over here, capturing that earthquake down here in this area over here, then that's artificially changing, right? So we're really interested more in this part of Kilauea over here, so we're going to ignore that bigger earthquake. And here, this map for the last week, you can see minor South Flank activity. You can see a lot of this deeper stuff happening all throughout, so a lot of deep adjustments happening. There is that deeper magma pathway, we believe, that comes through here, more or less, but it's not looking particularly active, especially, well, the seismicity is not revealing it right now, is what I should say. It could easily be active without the seismicity. It often does not have a seismicity. Sometimes it does, and when it does in these areas, we often associate it with that, right? Out here, more so the adjustment, perhaps. So that is the story with the earthquakes. Okay, so a couple last views here. This is the last 24 hours of the S1 camera looking from the south. This is the most active part of the lake now. This is west vent, new west vent, and that north branch and the south branch right here. And maybe you can see a little more easily the nature of this perched levee edge right here in the south edge, right, where we're wondering about these spillovers that come across and feed down. Right? That's not as visible, at least in the nighttime view here in this S1 camera. Something we'll keep an eye on. And the KW camera, the last 24 hours, time-lapse as well. You see some rainbows flying by. You can see Dane's post on the reason for so many rainbows in Hawaii on Hawaii Tracker. Was up this past week, if you're curious for that. You also see the daytime and nighttime views here, showing that same active perspective of the lake, similar to the thermal camera, right in there, right? And you can note here that our spillover point from the KW camera is really close to the south edge of the crater here. Not quite visible there, so maybe it won't show up in this S1 camera because it might be behind this rock down in here. And that is our current data for you guys.
All right. Well, we should go through our sponsors, thank them, and they really do help with this content, keeping it going and keeping these regular updates on schedule. But I also do want to thank first the viewers that showed up and maybe gave a like, subscription, or shared this video. That always helps. It's better than any monetary donation, really. Just helps get this channel out there, more eyes on it, and all that. It really does help out. We do take donations, though, on hawaiitracker.com/support, and we appreciate everybody that made donations on there. We do have a couple of sponsors that we want to shout out as well. First one is Kilauea's Bar and Grill in the heart of Pahoa, and they also have a second establishment in Orchid Land now. So check them out at either location, but they have two unique menus, so you're not going to get the same experience twice at each establishment. Definitely worth checking out for locals and for visitors. Indoor, outdoor dining, takeout options, all that for the COVID times. So yeah, we thank Kilauea's Bar and Grill for supporting this program. The second one is Kalani Tours out of Kona. And Kalani Tours does a few different types of tours, including waterfall tours, Kona Coffee Farm tours, and also the volcano tour, which is right now is the time to go. If you're going to, it's one of those rare opportunities to see the active eruption inside Halemaʻumaʻu crater. It doesn't happen all that often. So if you're coming out here, definitely check them out. We do have support from the Hawaii Community Foundation and the Puna Strong Grant through the County of Hawaii. We appreciate all them as well. We do have a $25 super chat that came through that had a question attached to it. It was from Langer1234, $25. We appreciate that. It's asked, does the weight, if all of that lava in the lake, have an effect on the weather? Will it force through lava tubes or fissures or end up coming out of other areas?
All right, so it's kind of two questions in there, right? The way I heard it, yeah. The first question is, will it affect the weather? And the answer is it certainly can affect the weather. But here's why I split it into two questions, because it doesn't do so by going through any tubes or anything like that. It does so just by piling in a big hole in the ground there and having a giant thermal mass in one area that's putting a lot of heat into the atmosphere. And not only is it putting a lot of heat, it's actually venting actively hot volcanic gas. And that's something we've seen before in 2018. It really can cause localized pyrocumulus, heavy showers. You can have all kinds of interesting effects of weather effects with that. That seems to be tied to the gas output as well. So I would say that when a gas output is really high is when you're seeing that, right? In 2018, it was similar. The gas output was high for a long time. That was part of the wonder and terror of Fissure 8, Ahu Ela'au, is that it just kept going at that high volume for so long, on and on, high gas, high lava values. So it seems like we might have had more of a weather effect at the beginning of the eruption when we had more gas coming out. We still have a lot of gas coming out now, but it's a lot less than before. And the island weather already is very dynamic. Having the trade winds come from the east, rising up the volcanoes, rising up Kilauea, rising up Mauna Loa, then making the crest, and the rain shadows and all that. It's quite complicated and localized as well. So that's kind of the first part. Yes, it does affect the weather, probably more locally and probably when there's more gas. Part two, there are connections, and this is worth addressing. And I'm going to maybe expand the question here to something else I've heard recently, Dane. Right? Part two, are there kind of cracks and lava tubes that the lava can go into and go elsewhere, right? And there certainly is a whole network around a summit area that maybe we're seeing moving, and the Upper East Rift Connector / Upper East Rift Zone to Pu'u, I consider it to be fairly open as like the hallway leading off the main living room of this magma reservoir area. So that's all fair game as far as movement in and out, and all that's not surprising at all, right? So all good there. So yes, within the open house area. However, other parts of the volcano, here's where I'm going to add on, like Pu'u has got a closed door, and right now the magma cannot get through there for whatever reason. And someday we know that door is going to open again, and it may not open all the way down to the lower East Rift Zone again, but open a little ways, and that'll be our next stage of Rift Zone development, so to speak. However, for anyone who's scared that the lava is going to drain out of this crater and go down like it did in 2018 and back to where it was, there is, first of all, no indication of that. Number two, we've still recovered less than 10% of the volume of lava and magma that we lost in 2018. Less than 10%. So we just don't have the chamber is not full enough to cause that kind of event we saw in 2018. I understand the trauma and I understand the fear of it. And, even if there were to be some kind of movement through the rift zone, it's not going to be anything as big as it was in 2018, right? Because there's just not that much magma as it was before. Just physically, it's not the same amount. And I know that's our biggest, one of our biggest reasons that we do this is to keep people in a lower East Rift Zone affected by the Pu'u eruption in 2018 informed. I also want to make sure to especially note that here, Dane. That, I'm sure is on people's minds still today. It's beautiful in the caldera, but when might it actually drain back to lower Puna? And no sign of that happening anytime soon. And not even nearly as much lava in the crater as it was in 2018. So we're nowhere near the same situation as we were then.
Right. Makes sense. We have a $10 super chat from, I'm going to probably get this name wrong, but I'm going to try anyway. Tupahu says, aloha pumehana, and appreciate that and all the support as well. Get into the next question here.
Yeah. I do see a note here. Yeah, 10% less in a year. So yeah, at the same rate, a decade. Yeah, sure. Yeah, in a decade we could get there, but it's going to take a decade of it doing the same thing. Yeah, it's a good point there.
That works. Kenny asked, and I already linked the video we did on the stream highlights forum, but maybe just a rough overview. How does this lake compare to the historical lava lakes in Halemaʻumaʻu pre-2018 and going back even further?
So the 2008 to 18 lava lake is the first pre-2018 lava lake. It was at a much higher elevation because the caldera was so much fuller, right? That's kind of the first thing. And as far as area, it was quite a bit smaller. This one, because it's filling the whole crater floor, it's a massive area. I mean, the massive active area is shrinking, but it's still massive. It's the largest one in the world at present, right? And, we'll see at the shrinking rate when it actually loses that title again, but that's the size of the thing we're talking about. Much deeper, broader, and changing compared to that era. Before that, there were lava lakes within the smaller crater of Halemaʻumaʻu. There was 67, 68, might have been the next notable one, was maybe a 8.5, 9 month lava lake that filled that pit. And we haven't gotten into a lot of detail about that one, but that's fairly similar to what we saw just in the end of 2020 to beginning of 2021, where it was filling the crater, building perched edges, and you saw some spatter island features in there, and maybe we'll go into that in the future at some point. But that one's kind of similar. Probably one of the more similar ones were the ones that formed since 24, because pre-24 was an era of famous lava lakes that occurred in a much narrower conduit crater within the volcano that had a semi-solid plug, and the lava lake was active almost all the time. Where like low-level activity would have been, there's 8 fountains going on at the same time today. That's low-level activity. And high-level activity, it's going on 40 at the same time, and it's coming all the way up, and there's crags and islands rising out of the lava and changing shapes and sinking back in and flipping over, and the whole thing is spilling out into the caldera floor. That would have been the most dramatic March 1921 event that we recapped in that highlight that Dane mentioned. Yeah, so there's some similarities and some differences.
I'll go ahead and drop that in chat one more time for anybody that wants to check out that video. We do have another question here from Eddie, who asks, how large is the vent that the lava is spewing out of? Rough dimensions in terms of like how wide is that fissure?
It's hard to tell. We'll maybe get some clues from some of these images that the USGS has, right? But what we can say is, let me see if I can find one to share here as a preview of what's coming up. They do say that the highest fountains that reached nearly 100 feet tall were reaching above the edge of that cone. So I think that's their measurement of how high the fountain, of how high the cone is. There it is. Let me switch it over. A picture from October 12th. One of these lava sprays that's coming up clearly above the walls of the spatter cone, right? So they've measured this spatter cone, I believe, is what I'm implying, 100 feet tall or so, right? So that's 100 feet or so. And that right there is 30 feet or so, that gap. Here, I'm going to draw it in yellow so you guys can see. The gap, 30 feet right there. And this area, 100 feet or so, more or less, right? Maybe what the caption says here. Above the height of the cone, 30 meters, 100 feet. Basically what that says there. So, as far as how wide it crosses it, and while I'm at it and we're on this picture, you can see here our 2.1 vent spattering just beyond it over here. They're saying it's about 3 meters, 10 feet high here in the back. This back one here. So if this is 30 feet, 10 meters or so, then maybe there's another one there, and there's another one there, and there's 2 more this way, right? Maybe we'll multiply it by a factor of 5 or so. And maybe 150 feet or so, 50 meters-ish, more or less, ballpark. The width of this thing, it's kind of, it's fairly circular, horseshoe shaped with this gap on this side, right? But it's probably roughly the same. So that's my estimate there.
And you think the hole in the ground that the lava is coming out through the previous crack is roughly that same size? It doesn't just like get bigger once it gets to that old elevation, and the rest is cone building?
Yeah, so I mean, I think that the lake level has reached the height of that original fissure. I don't know if I have a picture lined up of that original fissure to share. I can let's see.
Right. It was up on the wall a little bit.
If we go to the main HVO page, I can find this for you guys here live. We'll click on eruption information. I believe here at the very front, somewhere they have a view of this original fissure. There it is. The original fissures that opened up on that wall, right? So our main vent is this one we're seeing right here. That 2.1 maybe it's here, but it actually I think it could be this edge of it, right? And we're actually seeing the cone built around here, so we're really seeing just one fountain right there. You can see that there were other vents further up over here and all the way down over here as well. And so that gives you some idea. The lava lake has now come up to this level, and the cone is built up around it like that, right? Or maybe like that, with this little edge here on the side.
Okay. Erich asks, so the effusion rate, is the effusion rate much higher than the previous eruption? And just by observations of how it's been filling?
That's a hard question to answer. We have to rely on the volumes and to really estimate those rates, and the rates changed a lot at the beginning of the eruption. Our highest SO2 value of 85,000 at the beginning, really, it's a mixed bag, right? That's the highest value we've measured. So you might say, okay, that means the effusion rate at the beginning was higher. However, the measurement was taken just minutes after eruption began, so it was taken much earlier in eruption than the last measurement was taken at the beginning of the last eruption. So maybe you can't quite compare it, because if we have this kind of exponential changes, right? It's, the very beginning is changing the fastest, and so those few hours really matter at the beginning there. What's clear with this one is that the lava was bubbling up through that southern vent, through the lava lake, for much longer than we saw that happening during the last eruption. So that aspect of it does seem different, where we did have the fissure going through the bottom of the lake that actually was able to come up through the whole lake and bubble out that way, right? And maybe that's just the localized dynamics. Maybe, once you have a crack at the bottom, the gas bubbling up will just have that kind of appearance, but it did appear like it was able to come up through the lake for a while, and it has stopped doing that now, right? So it's been 2 weeks. It took just 1 week for the last eruption to drown its vent. So all that to say, it's pretty similar, and it's pretty similar. I could guess that it's slightly higher, and that might well be right, but it might be about the same in the end. And it's same order of magnitude. I would lean towards it being a little higher, but I don't have any data to support that as of right now. What we could do the last time, as far as estimating volumes, was we knew the lava lake was filling the whole crater, and the whole crater was essentially mostly flat, so we could then calculate those volumes fairly easily, right, from DEMs and all that. Mm-hmm. Now that we have not a flat surface and it's tilted, that complicates everything as far as trying to figure out how much volume is in there. And if you don't know how much volume is in there, then you can't figure out the rates as well. And that's the issue where we now have to rely exclusively on just putting out their numbers, however often they put them out, rather than doing our own calculations with without having the most recent DM of the surface as it appears anytime recently. Right? That's the big challenge there.
Makes sense. All right, we'll do this final question for this round of Q&A, and we'll take some more at the end of the program. This one is also from Kenny, who asks, do you think there will be another magma blob coming up from depth? Has deformation slowed, or is there any indication of DI cycles returning?
I haven't seen, I thought I might have seen some little hints of small DI kind of things, but nothing really convincing, and always superimposed on some other larger process happening. So I'm not convinced that there's anything major with that. It's really hard to see these blobs of depth coming up until they're really arriving. So I don't see any sign of anything arriving. I see those localized inflation at Halemaʻumaʻu, but not of the order of magnitude that we saw, like at the beginning of the eruption, for example, or during the intrusionary phase, right, about a month ago or so. So it seems to me like more likely the inflationary change has to do with the vent starting to be drowned by the lava lake there. And so that's the real question over the next week. Is a vent how much is that gonna impede that vent or like keep fountaining out up to 100 feet through that lake still, right? Which is the impressive thing.
Right. And if, for those that weren't following closely on the last eruption, like the vents would shut off once the lava lake got above them, just like a switch almost. And this one, I'm wondering if it'll shut off as well once it's right at that level, where it's starting to flirt with it. And how much higher can it really go? How much pressure does it really have? So that will be interesting in the next week. All right, well, that will do it for this first Q&A segment. We will be doing one more. And if I didn't get your question and you think I should, just go ahead and repeat it in chat and try and get it in the next round.
Mahalo, Dane. I did see a couple comments that have been coming in through the week that I'm just going to add this last observation here at the end. There's people talking about how this new west vent is a little closer to the southwest rift connector there, right? And people are speculating whether you might have magma interacting with that shallow southwest rift, right? And it's worth noting the last time that happened, that it was a time when Mauna Loa had been inactive for quite a while, and we see trends in times like 1970, like 75 when Mauna Loa was reactivating, when we don't see those southwest rift activations. So just throw it in there that southwest rift has got to do not just with Kilauea but Mauna Loa pushing back as well. Mauna Loa has been pretty quiet. We're not going to do Mauna Loa updates today. Well, maybe next week we'll add it back in. Quick touch base. There's nothing really changing there. That's the Mauna Loa update today. So maybe that's possible, but the fact you had so much magma coming into it earlier this year already maybe reduces the chance of that a little bit in my mind, right? As far as southwest rift interaction with that area, the lava lake area, vent area or so. All right, so mahalo, Dane, mahalo, you guys. Let's move on here, and we're gonna start off by showing you guys this video released by the USGS of HVO geologist Dr. Matt Patrick, making observations, collecting data, and maintaining instruments around Halemaʻumaʻu. So I'm going to play this. Turn off the wind here. You can see what it's like for the geologist, and so it's nice that we're looking at all these different cameras all around the rim, and might give you some idea of what all that looks like to be at different points in the rim. So there he is, looking at the west vent from just to the north there, right, probably the northwest edge, using the rangefinder, measuring lava levels, different points in the lake surface, visible from there. And then he's going to pack up and he's going to walk around to the next spot. You can see still different view there. You can see the protective headgear in case any unexpected rock fall, any kind of explosion or lava wafting in those updrafts, anything like that come up. So that's just standard practice. And you can see here, it's really interesting to see that that new west vent is at the base of that down drop block there on the west side. Probably one of the better views I've seen of that. All right, another observation point. You can see now he's on the south. You can see that west vent is over here on the left side of the image. And he's adjusting. I'm not sure what kind of data logger that is. It might be actually a light, and he's perhaps looking at the batteries, checking the batteries, kind of thing, adjusting, downloading the data. It's got a red flash as red there, so I don't know. Maybe that's it. Maybe someone can let us know what instrument that might be, if you have any better idea. Here another part of the installation, solar panels and batteries. You can see all the ash, perhaps wind blowing across.
Thing looked like a normal trail cam almost. I'm sure that's not what it was, but it almost looks like a trail cam.
It does, yeah. I wonder if that's one of those web cameras. What designs are using there. So mahalo USGS for that little insight video of the scientists at work. Many geologists doing that. That just happens to be a video of Matt, Dr. Matt Patrick, right there. So all right, we'll go back to October 8th from the USGS photo releases and go through some of this now. The rainbow. At the end of the rainbow is the west vent. The west vent, you can see from this perspective, there is that down drop western block. Right, you can see that the new vent is kind of at the base of it, a little bit slightly towards the north, but that helps us identify on a map of where that actually is. Right, the previous one is more against the side. right in there. Having since drifted, you know, now it's separated from the wall because the lava level has risen around it. So I'll go through some of these more quickly than others. You know, because a lot of them are certainly look a little similar by now. There's an active west vent. There's that north branch of it going that way, and the south branch is behind the haze in this direction here. And maybe you see a lot more of these fuming crater walls. You can see on this north side visible in this image here, from straight above here. And there's that west vent once again. And interesting to note here, this is a pretty good view of how that cone is building up, right? You see the cone is most of the way around with that small gap right there, right? So this is the one we said was 10 meters, and maybe that was 1/5 of this total distance that way, right? It looks like from this perspective, you can tell it's slightly oval. It's more elongated in the direction of the gap right there. And all the silver dispersal pattern of that thin crust riding on that lava surface that's beneath there. Not quite visible everywhere. Once you really zoom into the right areas, you can see the gaps between the crust showing red. There, for example. Right? You can also see very easily here this older west vent island. Right there, where you see the lava is lapping onto it here on the edges, but it's still essentially sitting high. It's lapping onto it more on the lakeside, and it's much higher relief on this backside where this channel exists. Right? It's essentially forming part of that levee. Right there. And the levee just barely visible. And some of these other segments in here as well. Right there and there, and actively breaching fairly often. Another close-up view of this west vent with a nice blanket of nice blanket of lava splashing down on this western side here. And that's, you can see how the cone builds. It's just layer upon layer of lava glob. If you've ever been at the beach and made those wet sand drip castles, similar thing. Just drip it on top, another blob and blob and blob, and at some point the blobs become unbalanced and a big chunk falls in. You just start over and over and over again, and that's how I've been building the cone, as you guys saw in that time-lapse version here, right? Down here at the bottom, there is that area that's 2.1, that's that slightly offset vent area. That's kind of upwelling right here, but it may actually be coming out of the side of the cone somewhere through here in the coming days. We'll have to see. This is before all of that happened. Keep going. A lot of pictures here, more of these interesting textures. We talked about this last week, about how that area is spreading laterally, and it's basically stretching out, and that allows lava to rise into those stretch zigzags, right? It makes that zigzag infilling pattern of lava right through there. Right? And you can see other places where it's broken apart and filled as well. Okay, this is the main central island here, and recently, several of the USGS captions are noting this coat of fresh spatter. We had several fountains on this side of the island early on, and they were throwing lava all the way up onto here. And it was landing all across here, right? And all the stuff kind of formed a lot of the spatter. But there was enough falling on this upper section right through here to actually leave a new lava flow. And clearly it moved and flowed down the other side of the island back over here. And that is ongoing as well. That other vent that lasted longer was down here and had a section up on this island up here. That stopped erupting, obviously. Still outputting gas, as you can clearly tell, quite a bit of discoloration right around there, and also down here with likely primitive volcanic gas coming out through the lake, through those chimneys. Think of them now. Moving on. A view from the south, there is our old crater rim drive that is on this kind of southwest down-drop block right here. This is all inside the crater with a road on it intact, and there's other pieces of road further down below here you can't see. Other images will show chunks of that lining up together. And below that block is another lower block here in the west. That's the one I'm calling that western down-drop block right there. That's at the base of that thing is our new west vent. Okay. We'll keep going. Another wider view here. You can see there's that was that road sliver right there from that perspective, and down drop block is down over here on the side. Our active lake here, north channel, south channel, and here's that edge of the lake where it may actually spill over onto this ledge right in there. That's that low spot right there. And zoom it in for you guys. Like, that's as close as we are from there to there. That's how far we gotta go. But this edge, of course, is quite a bit lower than this close edge where you can see all this active surface from the texture right here. All right. And we looked at this view here of the summit activity as well. So profiles, that's where this came from. I updated and showed you guys this video as well. Make sure we cover all the content here. Moving on to the next day of release, October 11th. There is that west vent once again. Similar patterns, except in the darkness of night. When many of the views that we're seeing shared on Hawaii Tracker are being shared, nighttime views when it's not quite as crowded, right? There's another view from that northwest angle. As you can see visually, the active surface is quite a bit smaller than it was last week. And looking through the laser range, or through the visual rangefinder here, visual scope, telescope, what am I trying to say here? Through the lens of a laser rangefinder, yeah. So it is a laser rangefinder scope here that they're looking at. You can actually see a better view of this cone, really piled up high against this back wall now, right? You can tell that from this image here on the 9th. There's a scientist taking video of the west vent. One of the videos we saw was likely from this videographer here. Photo credit by Julie Chang. And there's a west vent once again, but of more note, a Kīlauea white-tailed tropic bird, still nesting inside the crater walls, still flying around on those thermals. They swim to the ocean to feed and back, but it's just still fascinating to see those. You see those all the time there. And while we're talking about the fauna here, there is also nene in the area, especially on the Kanikakoi side. If you go in the early hours of the morning, see them flying quite often, quite frequently. Interesting how much life still goes on. It's just business as usual for nature on the volcano. Okay, October 12th. Another view of the west vent. There it is. Zoomed way in. You can see a lot of these textures of the side. And then let's see, maybe these are the chunks that perhaps try to form, but then get knocked over and pushed apart by this inflow. Going here. They're zoomed in, looking across this large island. So here's a big island, this large central island. The vent had been over here, was throwing lava onto it. And here's a flow that flowed down the side, right? They actually call this a rootless lava flow because it was fed by fallout of lava through the air. Video we showed you guys. And the one here as well. Series of videos. Not sure with you guys there. So those have all been included already. This is that picture I just put up for you guys that came from this October 13th release. So there's that view from the south. The double fountain view I just showed you guys with those highest peaks. And that 2.1 just to the north. Another close-up here, and in this particular view, you once again can see two zones of flow, perhaps because another one of these chunks is somewhere in here blocking this exit point, right? But it don't really last that long. And in the past, we've seen some of these chunks actually become little islets floating in the lake. I haven't seen as much of that happening yet, but that's a possibility as the lava lake gets higher as well. Another one of those high bursts of fountain above the lake here, above the cone here. Right? See, during this surge time. High peak here, bursting out the side from 2.1. I'm not sure what the better term for that is. And that's the 13th there. So we only have one more day, today's release, and we have one updated photograph here in daytime, the west vent, Central Island, Old West Vent Island right in here. And it's still business as usual. So those are all the details. The lake's still coming up, still filling up. It's still visible. We can refresh our current webcams across the summit to see all the different views here. So S1 camera, there it is. V1 camera. You see mostly constrained in this back part of the crater for now. Right? Not really any active flow moving presently down that southeast crater wall, where you might see it from the Uikahuna Jagger viewpoint in the north of the caldera. But also a curious bright spot right here in the middle of this zone, right? So it just goes to show you that there is still lava here, and there is still crust overturning, and you possibly could have some of these flashes in this foreground as well. That's not even visible in this view from the KW camera. That would be somewhere in the back over here. Really showing that active pattern all the same. Zooming out. There's zoomed out views. Our latest thermal view. We don't have that side vent active, but still very active west vent here. And we still have one of these big flows working its way to the southeast there. And that is a beautiful Mauna strip road, and that is most of the views we have today. Of course, I encourage you to go on hawaiitracker.com, Hawaii Tracker Facebook page here. It's going to load up for me in just a second. And you can see there's all kinds of posts on Kilauea, and not just Kilauea, other parts of the island, but you can see some vlog in Kona, see what the vlog is like. You can see pictures such as this one by Corey Thompson, which captures perhaps a profile of the volcano spirit there in the clouds, and maybe we'll just do that one as a tease for what else you might find interesting in Hawaii Tracker. So if you guys are on a Facebook page, check out the website. If you're on YouTube, check out the Facebook page, and etc. Work your way around and hit all the bases and like us in all those places if you can. And that is the content we can share with you guys today.
All right. Well, thanks for that. We do have a couple questions here. If anybody does have anything else to ask, go ahead and throw the chat now. We'll try and get to it. Last minute questions. I'm going to expand upon this question a little bit. James asks, what is the consistency of the lava below the crust of the lake? And my question then comes to what is the depth of the lava that is above the lakes, the lava that is erupting on top of the lake surface? We know that plug has essentially risen, right? But how deep is it between that molten layer? We go molten, hardened, molten again. How thin is that top molten section?
That's a good question. I mean, it's the fact that we saw from the thermal those back islands rise out of it makes me think it's not super deep, right? Of course the eastern section is different from the western section, but I would have guessed 20-30 feet ish might have been how much lava you had above that crust, right? And so if you think of it that way, and then you hear, there's a 9 meter, about 30 feet difference from the eastern edge to the western edge. Maybe it's piling, maybe the actual old crust is closer to level. I won't say it actually is closer to level, and it's all piled out on top of it on the west side, right? And on the east side, it's not piling on top of it anymore. So that's a possibility there. The crust itself, that's really hard to imagine. Based on the rates that we saw from Kilauea information. It might be similarly a few meters, 10 feet, 15 feet, maybe ballpark somewhere in there, So you might have, like a fairly thin layer of lava, right? If 30 feet is thin, like for a lava lake, right? Fairly thin, and then like another about that amount of crust, and then you have the most of your lava underneath that. And in that deeper section, originally you had a lot of degas lava from the first eruption, but it's been refreshed with all this newer, frothier stuff that probably churned it all up. So it's probably mixed it, and it might have been more gooey before, but you've basically added more hot stuff to the mix, and liquefied it more, right? For lack of a more accurate term, right? You basically made it more, made it less viscous by adding more gas and more heat to it. Be more precise there.
Definitely, and it's just there's a whole bunch of questions right around that, and even when I was compiling the thermal cameras, I was looking at it like, did the vent just start putting more lava above the lake surface as opposed to below? Like for a couple days there, I kept running it back and forth. Like, did we have a small change where it's now more lava is coming to the surface, or at least so we can see it? But it's so hard to tell, you know.
Yeah, especially now that we know that there's a perched pond, especially near that western side. So that perched pond is on top of that crust, which is on top of. So that's what, and so I'm tempted to describe that whole surface as just being inclined and tilted. But in that case, it was just constantly run down towards that south end or eastern end all the time, right? So it's not doing that. It's only overflowing it. So that west end's got to be flat, and then it's got to be tilted beyond that. It's kind of a weird thing going on there.
Interesting, for sure. Jack asked, do you think it's about the 6.1 or the 6.2? Maybe we'll talk about that just a touch more. Do you agree with that earthquake being the lithospheric crust breaking, as the USGS reported?
Yeah, I don't see any reason to disagree with that. Really, it's the depth, like I mentioned before, the depth of it, the lack of any migration, a lot of aftershocks, right? But they were all at the same depth, more or less. Like we didn't see anything going from 20 miles to 15 miles to 10 miles, 5, nothing like that, right? It was all just in one area. And sometimes sometimes you actually get a whole bunch of earthquakes in the shallow part above that as an adjustment above that. We didn't even see that as much. So it makes me believe it really was all down at the base of the lithosphere there.
One of the interesting things about that one was the revision that USGS made on that earthquake, and in the initial parts, it goes from that automatically generated signal to getting refined from other systems, and then it gets reviewed by a seismologist, and they make those final adjustments to it. But in the initial one, it came out and they were like, oh, it's 17.1 kilometers down. I'm like, oh yeah, it's the flexure of the crust of the earth. It's one of these lithospheric earthquakes, and I started writing it up as such. And then the revision came across it, and the depth of it doubled. I was like, well, it's still it's still the same.
Same conclusion, but even more drastic. Yeah.
Yeah.
So is a couple interesting things to touch on there, right? Because there's a lot of I don't know what to call it. A lot of confusion about the process USGS takes of how all the earthquakes come to be on our web pages and how they appear or disappear or get revised or what have you, right? And as if those of you guys haven't heard, when I first worked with the USGS as a volunteer, that was my job, was to work on an earthquake reporting system, right? So I can tell you how automated the whole thing is, and what I can tell you is the computer has been getting smarter, but it's still just an algorithm that's trying to do the best with natural earthquake data. You guys ever looked at the seismogram and seen how many wiggles are in that thing? Try to write a program to pick exactly the right wiggle every time is incredibly hard to do, right? That's why it takes manual revision and confirmation most of the time for that to happen. So it seemed like this earthquake in particular, a couple of things. One, when it's so far down, think of it as being totally outside of the network, right? Ideally what you want is you want your network to be designed so that you have any event happens within a perimeter of the network, right? You want to be able to see it from all different angles, right, from the sides. Once it gets to be 35 kilometers down, now it's down from everywhere a long way. So it's outside of your sphere of measurement. So that makes your error larger potentially whenever you have that kind of thing happening. So any earthquake that's really deep or offshore, because we don't have as many seismometers on the ocean bottom, those are the ones that have the largest errors that you can expect. That's kind of part one. And then part two is, as a consequence of that, sometimes the computer might pick out two different earthquakes and say, oh, this is actually two events, and one happened at this shallow depth and one happened at that deeper depth, and that's what it thinks is what's going on. But actually there's not two events, it's one event, and it's shaking things differently. It just got really confused, and it takes it's different kinds of babysitting, right? Oh yeah, the kids are fine, like they're playing on their own, or they're fine, or good. That's possible. Okay, now I got some cleanup to do and clean up all this mess of what I was babysitting because it just didn't work out in the most well-behaved way, we'll say, right? So
yeah, We've seen every kind of revision, and really it's the one thing you look for is that reviewed status on the USGS site. Just because then once it's reviewed, it's like, all right, the likelihood of it changing now is drastically cut.
Yeah. So
before that review happens, it's wild sometimes. Like it can go on a tangent.
For sure, and that's why you know the guys will get out of bed in the middle of the night to review this thing immediately because it matters for everything that comes afterwards, right?
Right.
And the thing is that those of us that are watching the earthquakes the most closely, that actually notice the report before it gets updated, before it gets reviewed, or notice 2 revisions to it. We're the ones watching the most closely. We actually get a little bit of a peek behind the curtain of this process, right?
Right.
But those same ones of us are the ones that might be the most skeptical of, like, wait a minute, where did an earthquake go? And like, oh, what happened? You know, so, but that's the nature of it and why it happens, right? You know, the people who are watching the most closest might be the most skeptical. That might go hand in hand, right. But you know, if you can just exercise that patience till it actually gets reviewed, then that's the real deal, as opposed to just really some dumb computer that, you know, might have been me programming when I was 18 years old, to give you some idea. You know what I mean? Like something, who knows, you know? So.
And that might be true. Who knows? It might actually still be the same script in a lot of ways in some places. It's definitely interesting, that whole thing. I believe we have gotten through most of the questions, though.
Let me add on here. I just saw our Volcano Watch.
Yeah, do it.
Our Volcano Watch was just published.
They got it out.
And it's, you know, large earthquake reminds us to drop cover and hold on. And this is just worth mentioning, you know, of course, like what to do from volcano, you know, as far as responding to volcano. So I just want to mention that this is out, and we will post that on hawaiitracker.com with more information there. So, but basically, one thing to note: deep earthquakes do not generate tsunami. Right, when it's that far down, you can largely discount tsunami. So that's a whole other can of worms to discuss at a different time. You know, what causes tsunamis, what don't. But you know, it's just as a corollary to what we were just talking about. Nothing to worry about that as well.
Yeah, we might have to do a video on the shorthands of tsunamis and where to watch for earthquakes and something like that.
Right.
Yeah,
so
that might help people.
Cut to the chase with this Volcano Watch. There's essentially an awareness campaign that happens every year called the Great Hawaii Shakeout. International Shakeout Day is the 3rd Thursday of every October, so that's coming up here. And so this year on the 21st at 10:21 a.m., they are inviting everyone to practice drop covering and holding on as well. So, and you can read on from there, right? So that's just a little add-on here to the earthquake discussion, since we probably won't mention the earthquake again.
Yep. And I mean, my reaction for that last earthquake was look over and nudge the dog, because I thought he was the cause of it at first. I traditionally miss all of the earthquakes in terms of feeling them. So halfway through blaming the dog, I'm like, wait, something's actually here. But all right, that'll do it for the question and answer segment, and appreciate the time you put into this. We do have a Drones On coming up that will premiere immediately after this live stream. This one's covering July 7th through the 14th of the 2018 eruption. We cover some of the losses of the Halemaʻumaʻu Warm Ponds and the Kūkala Charter School, and talk about some of the surges and look at some of the footage that the USGS released of those surges taking place from the air. So that will premiere immediately after this, and hope to see you guys there.
Yeah, mahalo, Dane. There's a lot more questions. We'll try to do more questions next week, and we'll try to answer those more in the chat. I know there's a lot of people who are, you probably not the ones watching still now, but people are, I do hear people are missing the short videos. I'll try to get more of those going as well. For those of you guys who don't have an hour and a half, hour and 40 minutes now to get to the end and hear that kind of message. So mahalo, everyone. Mahalo for your support. Mahalo for your interaction and the questions. Great thing we got going here. So see you guys next week. Make sure to check out Drones On coming up from hawaiitracker.com. He's Dane DuPont. I'm Philip Ong. Aloha, everyone.